All right, number 1. We are going to take h and add it to g. So since we're adding two things, we don't need any parentheses. So we have a squared minus 4 plus 2a minus 1. Now it's just a matter of combining like terms and putting this in order by degree. So I'm going to put my notation in the front, which is h plus g of a. And then I'm going to add like terms. So a squared is my biggest degree term, so I don't have anything else to go with that. And then we have the 2a, so plus 2a. The only thing we have to put together is the negative 4 and the negative 1, and that adds together to make negative 5. All right, number 2, we're subtracting, so we do need to use parentheses because what comes behind the subtraction sign is a binomial f of x. So we want that subtraction sign to go to both the 3x and the negative 2. Now since g is in front of the minus sign, you don't need parentheses there. So I'm just going to write that down. Minus, and then f is more than one term. So since I'm putting that back there behind the minus, we're going to put it in parentheses. So now we're going to distribute that negative sign. So a negative 1 times 3x would give me negative 3x. And a negative 1 times negative 2 is a positive 2. And now we're ready to put this in order and combine like terms. So I'm going to go ahead and put my notation in the front. And then we have x and negative 3x, which makes negative 2x. And then negative 4 and positive 2, which makes negative 2. Number 3, we are multiplying, and if you look at h is a binomial, so since we're taking that times something, we need it in parentheses. And we're taking that times g, which is also a binomial, so we're going to need that in parentheses as well. So we're taking all of h and multiplying that by all of g. And now we just multiply those together. So x times negative x is negative x squared. Negative x times 4 is negative, oh, that's a positive x, times 4 is positive 4x. 1 times negative x is negative x, and 1 times 4 is positive 4. Now I'm just going to put this in order and combine like terms. So I have h times g of x is equal to, and then I only have this 1x squared here, so negative x squared. 4x and negative x go together to make 3x, and then I have the plus 4 that's all by itself. All right, number 4, we are dividing, so I'm going to take f and put that on top. And g is going to go on the bottom. All right, and then I see that I can factor the top and the bottom, so I'm going to do that. But before I do, I'm going to go ahead and take care of the fact that there is an x in the denominator, and there are some things that we need to avoid. We don't want a 0 down here, so I'm going to take that negative 3x plus 3 and set it equal to 0 to figure out what I would plug in for that x to make that an issue. So we're going to subtract 3. That gives me negative 3x is equal to negative 3. And then I divide by negative 3. So x is equal to 1. So I know that when x is 1, that's going to give me a 0 in this denominator down here. So negative 3 times 1 would be negative 3 plus 3 is 0. So I know that in the end, x cannot be 1. So I'll put that in my answer at the bottom. So I'm going to go ahead and factor the top. I see that I have a common factor of x. So I'm going to factor that out. That would leave me with x squared plus x minus 2. And then I'm also going to go ahead and factor this trinomial. So keep the x out front. I've got a minus in the back, so 1 positive, 1 negative. I've got that x squared in the front, so x and x. And what multiplies to make 2 but subtracts to make 1 would be 2 and 1. And then I need that middle to be positive, so my 2 needs to go with the positive, and my 1 needs to go with the negative. On the bottom, I see that I have a 3 in common, but when that first term with that x is negative, I like to take the negative out with it. So I'm going to factor out a negative 3. So negative 3x divided by the negative 3 gives me x, and 3 divided by negative 3 gives me minus 1. And I see that I have a factor of x minus 1 on top and x minus 1 on the bottom, so I'm going to cancel that out. And that's all I have that's in common between the top and the bottom. So I'm going to go ahead and multiply this x back in. So x times x is x squared, and x times 2 is 2x. And then on bottom I have a negative 3. Now I don't like it when there's a singular term on bottom with a negative, so I'm going to divide everything by a negative 1. So that gives me negative x squared minus 2x all over positive 3. So that gives me f divided by g of x is equal to this. All right, I also need to state that x cannot be 1. Okay, sometimes you can factor the top and the bottom and nothing cancels, so you would just leave it as is. But if you do have an x in the denominator, set that equal to 0 so you know what x can't be. All right, so we're going to do some compositions. We're going to take g and plug into f. So I'm going to go ahead and write f down, but wherever I have an x, I'm going to replace that with g. So I'm putting a big space holder right here for x, and then I have minus 4. So in place of the x, I'm going to put g of x in, which is 3x cubed plus 2x. And then it's just a matter of simplifying. So I'm going to distribute this 4. That gives me 12x cubed. And then 4 times 2x is 8x. And then behind that I have a minus 4. Now I have no like terms, and this is already in order. So I'm just going to put my notation in front. And that gives me my answer. All right, number 6. This means the same exact thing. This is still g of f of x. All right, it's kind of like just a different notation. All right, so we're still plugging f into g. So you can think of it as being f into g. So I'm going to write g down. Now, if you'll notice, this x does not have a power. It doesn't have anything it's being multiplied by. So we don't need parentheses here. So I'm just going to replace this x with the f of x. So negative x squared minus x. So I'm just taking this out and putting this in. And then you still have this minus 5. Now, I look at this and I see that I don't have any like terms, and everything is already in order. So I'm just going to put my notation in front. You can choose to write it whichever way you prefer, and that would be your answer. Number 7, same thing. We're plugging h into g. Now, if you look at x and the g, there is something being multiplied, so we do need parentheses. So negative 4 times. We're going to be plugging h in there, minus 4. So I plug h, which is negative x cubed, plus 2x squared in. And then I simplify. Negative 4 times negative x squared is positive 4x squared. Negative 4 times 2x squared is negative 8x squared. And then back here we have that minus 4. All right. Oh, that's supposed to be a 3. So this should be 4x to the third. All right, so everything's in order. I don't have any like terms, so I'm going to put my function notation in the front. All right, number 8, we're plugging g into g. So I'm going to write g down like we normally do. But where that a is, I'm going to put some parentheses. And then we're plugging g into that. So negative 2a. And then we multiply. Negative 2 times negative 2a is positive 4a. And that's my answer. So g of a is equal to 4a. All right, so we're going to start with the g of negative 1. These are normally the problems people miss just because they're not paying attention, I guess. So start with this. So we're going to go to g and plug in negative 1. So I have negative 1 minus 5, which gives me negative 6. So I know that g of negative 1 is negative 6. So now I'm going to go to h and plug in negative 6. All right, so h is 4 times negative 6 minus 2. So 4 times negative 6 minus 2 gives me negative 26. So I know that h of g of negative 1 is equal to negative 26. All right, so we're going to do the same thing here. We're going to start with the g of 3 and figure out what that is. So I'm going to go to g and plug in 3. So I'm going to replace that x with a 3. So negative 2 times 3 plus 4, which gives me negative 2. So I know that g of 3 is negative 2. So I'm going to go to f and plug in negative 2. So f of negative 2. So I go to function f, and everywhere I have an x, I'm plugging in negative 2. So I've got negative 2 cubed plus 4 times negative 2 squared. All right, and you can plug that in your calculator just like it looks, and that gives you 8. All right, so we have f of g of 3 is equal to 8. All right, now we're actually finding the inverse. So remember, this represents y. So I'm going to switch the x and the y. So x is going to go where the y is, and then y is going to go where the x is. So now I'm just solving for y. So I can't get to y yet because y is under this root. But I can't get into the root yet because there's a number on the outside of the root. So I'm going to subtract that number first. So that gives me x minus 2 is equal to, and then on this side we have the fifth root of y minus 1. So I can't add the 1 yet because the 1 is still inside of this root. So to get rid of the fifth root, I'm going to take it to the fifth power. Now since there's 2 terms on the other side, I have to take the entire side to the fifth power. So this cancels out over here, and I have y minus 1 is equal to x minus 2 to the fifth. Now, if this was squared, I would probably want you to multiply that out. But since it's to the fifth power, that would be a lot of work, so we're going to leave this as is. So the last thing I do is I add 1, and we're just going to tack that onto the back. Do not try to add that to the negative 2 because that's inside a group that's already been formed. You can't infiltrate the group. All right, y is by itself, so I'm going to put my inverse notation. So g inverse of x is equal to x minus 2 to the fifth plus 1. All right, same thing here. Remember, this represents y. So I'm switching x and y. So that gives me x is equal to negative 1 over 3 times y minus 4/3. So I'm solving for y, which means first I need to get rid of this number that we're subtracting back here. So I'm going to add 4/3. So on the left, I have x plus 4/3 is equal to negative 1/3 times y. Since I'm multiplying y by a fraction, to get rid of it, I just multiply by its reciprocal. So I'm going to multiply by negative 3. Now, since I have 2 terms over here, I have to multiply both of those by that negative 3. So the negative 3 times the negative 1 over 3 cancels out. Y is by itself, so I'm going to put my inverse notation in. G inverse of x is equal to, and then I'm going to distribute this 3, so negative 3 times x is negative 3x, And negative 3 times 4 over 3 is equal to negative 4. All right, for these last two, they're asking us to state if they're inverses. So what we're going to do is we're going to graph them and then look at them. You don't have to do all of the work. We're going to use the calculator to our advantage. So in the y1, I'm going to put the h of x. If you have the Python calculator, you can get a fraction that way. If not, you have to go alpha y equals and enter. All right, so I have 4 over x minus 2, and then out to the side plus 2. All right, and then the inverse they're showing is exactly the same, so we'll see 4 over x minus 2, and then plus 2. So this is going to be a kind of a different looking graph. All right, notice that the blue one drew right over the red one, and so that's a little bit different for us. So we're going to look at this, and we're going to have it draw the inverse of the blue one. So the blue one is directly underneath the red one if you were watching this. So if we draw the inverse of the very first one and it draws over the red one, then it's just an inverse of itself. So we're going to go to the Draw menu, which is second, and Program, and then we're going to choose option 8 for Draw Inverse. And then we have to tell it we want to draw the inverse of the equation that is in the y1. So we go to alpha and trace to grab that y1 right there. So press enter. And then we're going to press enter again. And if you notice, the blue draws over the entire red. I know that sometimes there's a little red peeking through, but that's just because the calculator has a hard time drawing curves. So it mapped right over the red one. So yes, these are inverses. All right, and we're going to do the same thing with number 14. We're going to plug that first equation into the y1 and the second into the y2. So clear out what you have in there. So for the y1, we have negative 5 over 2 times x plus 5 over 2. All right, and then the second equation is negative 2 over 5 times x plus 2 over 5. All right, so this does not look promising to me because if I throw that mirror in, which we've talked about before, which is just x, remember it should cut through and make a mirror. So like if you have a blue here, you should have a red here, all right? And you don't. Also, it should cut right through where they meet. So if we try to draw the inverse, I'm going to go ahead and take that mirror out. If we try to draw the inverse of that first equation, it should map over the second one. So when I go to the Draw menu and I choose Draw Inverse, which is 8, and then Alpha Trace to find that y1, press Enter. My blue one, right, that graphed first, it should graph immediately over the red. But see when it drew that one in, it didn't draw over the red one. So therefore, the red is not the inverse of that first one. So the answer to this is no.